Okay, today we will learn on nanometers category. Okay, chapter 5. Okay, so we can see here. Okay, topics. There is only three minor topics that we will cover. First is on carbon-based nanomaterial, and then outside-based nanomaterial, nanocomposite based material. Okay, so for today, I will go for carbon-based nanomaterial. Okay, and then after that, I will give you the full notes for these topics, and then we will discuss for the next session. So, okay, yang ni based on your previous experience, okay, ataupun your previous semester, okay, I think you have come across with this term which is allotropy. Okay, so what is allotropy? Anyone? Ada yang tahu tak?
Saya tak tahu.
Tak tahu.
Tak tahu.
Pernah dengar?
Tak.
Tak.
Oh, tak. Okay. I think you kena ni balik kot. You kena ingat balik. Okay, so what is allotropy? So allotropy ni adalah existence of a chemical element in two or more forms. So that means it has more than one forms. Okay, so for carbon it has more than two, which is you can see in the slide, which is graphite, diamond, fullerene, and carbon nanotube. Okay, so the difference is their arrangement of atom in crystalline solid or in the occurrence of molecule that contain the different number of atoms. Okay, so yang tu dia punya difference. Okay, so now, okay, so as you can see here, okay, this one is more clearer, allotropic forms of carbon. So you can see here, okay, so we can divide it. The first one is graphite. Okay, for those who are familiar with chemistry subject, okay, this one, if you still remember what we call if you learn in chemistry, so this one, the graphite is formed by the sp2 hybridization, okay, which is a planar base. Okay, you can see the structure here. Okay, this one is the planar base of carbon, one layer, this one the second layer, the third layer, and so on. Okay, so you can see here each carbon atom in graphite is joined to only 3 other carbon atom. Okay, so this one is the weak forces, okay, between the forces that hold the each layer of the atoms. Okay, so this is the form of graphite. And then the second one is diamond. Okay, this one is based on sp3 hybridization, or also known as a cubic structure. Okay, this one it has a high temperature and pressure. Okay, and this is the form of diamond. Okay, yang you tahu yang diamond, the real diamond tu, the structure tu, if you can see, kalau you pergi you try pergi kedai emas, kalau ada yang jual after ni lah, after PKP ya, if you can go, you can see this kind of structure, the diamond structure. You just ask apa nama dia punya sales girl, okay, you ask, you kata you nak tengok dia punya diamond structure tu, so dia akan bagi one spec yang specialized untuk you tengok dia punya diamond structure. Okay, yang tu kalau you nak tengok, okay, you can ask dia free je. Okay, if you interested, you can go to any jewelry punya ni, dia orang ada. And then the third one is nanotube or fullerene. Okay, so this one is the combination of sp2 and sp3 character, okay, which is in cylindrical shape. Okay, for this topic we will discuss, or we will focusing more on the nanotube formation. Okay, so the nanotube formation, okay, what happened is in nanotube formation, it will eliminate the dangling bonds and also increase the strain energy. Okay, the strain energy is energy within the atoms. Okay, so what is carbon nanotubes? Okay, we will focusing between these three. Okay, we will focusing on carbon nanotubes. Okay, so what is carbon nanotubes? Anyone? Any idea? Or any one of you have come across any carbon nanotube application that you use in your life, or you have come across on these terms anywhere? Pernah nampak ke perkataan ni? Mungkin you tak perasan. Ada tak? Anyone? No? Okay, siapa pernah main badminton? Anyone?
Saya.
Saya.
Okay,
No.
okay. Your badminton racket tu is one of the application of carbon nanotubes. Okay, they gunakan carbon nanotubes to make your badminton racket. And then another application, pernah tengok now orang banyak yang cycling, right? Kan? So the bicycle that they use to, yang ringan-ringan tu, most of them are made from carbon nanotubes. Okay, so this is the material. So what is carbon nanotube? Okay, as you can see here, okay, we have two kind of, it's not two kinds, it's formation of carbon nanotube. The first one is the open ends. Okay, you can see here, dia tak ada maksud dia hollow. And the other one is the carbon nanotube with closed end. Okay, dia tutup dekat bahagian ends to ends. Okay, so carbon nanotube ni dia adalah tabular form of carbon with diameter as small as 1 nanometer. Okay, the tiniest size that they have lah. Okay, which is 1 nanometer. And the length, okay, dia punya length ni can go until several micrometers. Okay, micrometers, if you can imagine, it's just like macam your hair tu kan, rambut you tu, dia punya your thickness of the hair is micron size. So dia punya length tu you can imagine it will form between that kind of size. Okay, itu dia punya length. So can you imagine yang tu dia punya length, and then the diameter tu is in nanometer, which you cannot see by your naked eyes lah. Okay, so carbon nanotubes, they have the highest strength to weight ratio, okay, of any known materials. Okay, so dia adalah antara yang material that available which is the most maksudnya paling ringan, okay, compared to others. Okay, but although the nanotubes are strong, they are not brittle. Maksudnya dia tak senang brittle. What is brittle? Anyone?
Rapuh.
Tahu pun. Okay, so they are not brittle. Okay, so they can be bent. Okay, macam your racket tu kan, you can bend. If you perasan racket yang boleh bend tu, they are more expensive. Okay, and when released, they will spring back to their original shape. Dia punya function is like what you call, dia ada spring punya ni sikit. They can turn to their original shape. So one type of carbon nanotube has a cylindrical shape with open ends, this one. And types tu yang saya cakap tadi, okay, which is the closed end, okay, formed by some of the carbon nanotube combining into pentagons, okay, bentuk pentagons, okay, this one, pentagons, on the end of the nanotube. Okay, so carbon nanotubes can occur as multiple concentric cylinders of carbon atom called, the first one is multi-wall carbon nanotubes. Okay, this one they have more than one layer of carbon nanotubes, and the other ones we call as a single wall carbon nanotubes. Dia cuma ada one layer. So if you can see here, this one is multi-layer. So dia ada a few layer of carbon nanotubes. Kalau dia ada just one layer, that one is the single wall. Okay, so both of this multi-wall and single wall carbon nanotubes, they can be used to strengthen the composite of nanomaterials. So if some of the manufacturer, they use carbon nanotubes as composite, they just mix it with other material in order to strengthen their materials. Okay, dia campur dengan material lain. Contoh macam the previous one, they make alloy. Okay, so lebih kurang macam tu. So they mix this carbon nanotubes into the existing material in order to strengthen their existing material. Okay, so why carbon nanotubes are so special? Okay, so kenapa kita gunakan carbon nanotubes? Okay, so the first one that I have mentioned before, it is the strongest and most flexible molecular structure. Okay, sebab dia adalah the carbon punya, kita panggil apa, the network. Okay, carbon covalent bonding. Okay, and seamless hexagonal nanostructure architecture. And then it also have a Young modulus over 1 terapascal. Okay, 1 terapascal, which is higher than other material. Okay, contoh for single, if you compare single wall with multi-wall, okay, sini pun ada the different. Okay, both are in terapascal compared to steel. Okay, steel only 230 gigapascal. Okay, which is 100 times more. Okay, this one in gigatera. So the difference is, this is 10 power of 9, this is 10 power of 12. Okay, so quite big difference. Okay, aluminium pun around 700 gigapascal. Okay, which is, kalau tengok ni, around 500 times stronger than metal. And then it also have a maximum strain. Okay, and then thermal conductivity. Okay, high thermal conductivity, which is around 2000 to 3000 watt per mil Kelvin. Okay, and then when you add this carbon nanotubes, okay, it also will enhance the electrical conductivity. Okay, lebih higher than copper. So normally kita guna copper. If you know, for electrical punya supply that we use in our house, we are using copper. So by using carbon nanotube, we actually can increase the conductivity 6 times more than we are using copper. So another benefit of using carbon nanotubes is we can tune the band gap of the material. Okay, so we can switch the band gap for specific application. If you want to use for sensors or for solar cells, for any other optoelectronic applications, you can tune the band gap. And then it also have a very high current carrying capacity. Okay, it also can be functionalized. Okay, that means we can add on another material in the carbon nanotubes to enhance the application or the performance of the material. Okay, so here is the carbon nanotube family. Okay, Okay, before that, do you have any question to ask? For
No,
now?
sir.
Okay, so can we proceed?
Yes.
Okay. Okay, so we have three types of carbon nanotube family. Okay, the first one is the armchair. Okay, the zigzag and the chiral form. Okay, so as you can see here, okay, this is the formation. So you can see the difference, the horizontal and the vertical form. Okay, it's the same. Okay, so you can see here. Okay, I will show you. Okay, this one is okay, let me show you this one. Okay, okay, so you can see this one. Okay, the n and m ni dia punya integer, kita panggil integer, the value of integer. Okay, okay, this one n m. Okay, so if the integer, okay, or the length of the integer is the same, okay, 5, okay, or any numbers which is same, n is equal to m, so it is in armchair, zigzag, n have a number 9, m must equal to 0. For chiral, the number will be different. Okay, the integer will be different. So this is the value of the theta. Okay, theta is, okay, if this is your carbon nanotube, okay, so this one is your chiral vector. Okay, so this is your integer, this one is your integer. Okay, so this one is the chiral angle. Okay, so this theta is must be between, for armchair is 30 degrees, zigzag is 0, for chiral is between 0 to 30 degree. Okay, so this for this formation, okay, the electrical properties of carbon nanotubes are depend on how the hexagon are oriented along the axis of the tube. So these three orientation will affect the electrical properties. So armchair carbon nanotube have electrical properties similar to metals. Okay, which is very conductive. Okay, when you apply a voltage between two ends of armchair nanotube, okay, a current will flow, and armchair carbon nanotube is a better conductor than copper or any other metal, okay, that I have mentioned before, okay, which is it has a 6 times higher conductivity compared to what we call copper. Okay, so researcher now are developing methods to spin carbon nanotubes together to make low resistant electrical wires that could transform this electrical power grid. Okay, power grid yang dekat apa nama power voltage house. Okay, kalau kita ni macam PNB pembekal apa elektrik tu kan, reduce the power consume. Okay, untuk turunkan apa kegunaan power. So kalau power consume is low, means bill elektrik rendah lah. Okay, and reduce the weight of wire in weight sensitive uses like spacecraft and airplanes. Okay, and then they are also considering using armchair carbon nanotubes to replace the metal lines in integrated circuit. Okay, so most on metal lines in integrated circuit now kita banyak gunakan, siapa tahu kita guna apa? Most of integrated circuit now we are using apa? Anyone in your phone apa semua tu, in your circuit kita guna most of electronic appliances we are using. Anyone basic punya knowledge, we are using gold lah, tahu kan? Dalam your circuit tu, formation circuit tu, most of the apa nama channel semua tu we are using gold now. So they are research on considering to use carbon nanotubes to replace. Okay. Okay. Clear ke yang tu?
Clear, sir.
Okay. Okay, can I go for zigzag now? The zigzag carbon nanotube. Okay, so the zigzag and chiral carbon nanotubes, okay, dua-dua ni they share electrical properties similar to semiconductor, which is dia punya properties, the conductivity is lower compared to armchair. Okay, so these two configuration of nanotubes will only conduct an electric current when extra energy in the form of light or electric field is applied to free electron from the carbon atom. Okay, unless memang dia takkan conduct electric lah. Okay, there must be a extra energy in form of light or electric field. Okay, yang kena which we have to apply. Okay. So these semiconductor nanotubes could be useful in building smaller transistor used in integrated circuit for all kind of electronic devices lah. So whichever electronic devices we can use the zigzag and chiral form. Okay, and then another interesting property of carbon nanotube is their electrical resistance changes significantly when other molecule attach themselves to their carbon atoms. Okay, usually macam companies, okay, they will using this property to develop sensor that can detect chemical vapor, macam carbon monoxide or biological molecules. Okay. Okay, so that is one of the application. And then these nanotubes pun boleh kita bond with other material to form super strong composite. Okay, which I have mentioned before. This material can be mixed with other material to form another new material. Okay, so there are several reasons, okay, why we deposit or we form another new material using carbon nanotubes. Okay, so basically carbon nanotubes, they have a natural capacity to form covalent bond with many other elements because of a property called electronegativity. Okay, electronegativity, ingat this term. Okay. So electronegativity is a measure of how strongly an atom hold onto electron being about it. Okay, so because carbon has an electronegative rating in the middle of the range, it can form stable covalent bond with a large number of elements. So it is possible to combine these carbon nanotubes with other materials. Okay. So all the carbon atom in nanotubes are on the surface of the nanotubes and therefore it is accessible to other atoms. Okay, so the carbon atom in nanotubes are bonded to only, if you can see before that I show you, okay, for this one, they are only bond with 3 other carbon atom. Okay. So they have the capability to bond to 4 atom. Okay. So this factor make them relatively easy to covalent bond a variety of atoms of or molecule, which will changes the chemical properties of the nanotube. So while when you are combining the material with carbon nanotubes, they will change the properties, especially the chemical properties. Okay, so this combination or composite are called as functionalization. Okay, which I have mentioned in the previous slide before. So taking this bonding together, okay, so if the molecule attached to the carbon nanotubes also attached to carbon fibers, So these functionalized carbon nanotubes can bond to the fibers in composite, producing a stronger material. Okay. Okay. Okay, now we can, I'll show you the diameter, how to calculate the diameter of the tube and chiral vector. Okay, so here, the chiral vector is the formula. Okay, so the chiral vector is equal to NE1. A is this one, the, what we call the, length. This one is kita panggil apa, the fixed value, dia punya fixed value. Kejap lagi saya tunjuk what is the value. Okay, so this one is the integer. Okay, integer n times a1, okay, plus integer m times a2. So you will have the value of chiral vector, which is ch. Okay, and then the chiral vector here, ch, okay, can be described in terms of the lattice translational indices, which is this one, n, m, okay, and the unit vectors a1, a2. Okay, so this one, equation 1, you consider this one as an equation 1, and then this CNT is characterized by its chiral vector, which is this one. This one is the chiral vector. Okay, and then the theta here, we want to find the theta. So the theta is the chiral angle, okay, with respect to the zigzag axis. Okay, okay, so the chiral vector, okay, they are determined by the degree of twisting the tube. Ada soalan ke?
Kelas kami yang pukul 3 dan nak mula.
Ya.
Kelas kami yang pukul 3 dan nak mula.
Okay. So I stop for now. So I will give you the detail after this. Okay, here I want to share to you the synthesization method to produce carbon nanotube. Okay, so the first one is the carbon arc discharge. Okay, which is usually used to synthesize C60 fullerenes and also for the production of carbon nanotubes. Okay, in this method, okay, two carbon rods will place facing each other with about 1 millimeter gap, usually in an enclosure that is filled with either helium or argon gas. Okay, even they also have water. They are using also a water medium. Okay, and this arc vaporization of carbon will create nanotubes. Okay, so now I will show to you some of the experiment for the synthesis, how to get the carbon nanotubes using this method. So I will show to you. Okay, so this one is the experiment to synthesis the carbon nanotubes using a water medium. Okay, so as you can see here, so after doing this for about a few minutes, okay, usually just about 2 to 5 minutes, so everything will get hot and the water will start boiling, and then the color of the water will get grayish color, so as an identification that the carbon nanotubes is being produced. So you can see here, so the carbon electrode. Okay, so you can see what happened in the water medium. Okay. Okay, now I will share to you the method how to produce carbon nanotube by using CVD method, okay, which is chemical vapor deposition. Okay, so this video is from the NanoCat group from University Malaya. NanoCat, the short name for Nanotechnology and Catalysis Research Center. So I will show you the video so you can see how the process to deposit or synthesize the carbon nanotubes. So they are using a powder or activated carbon as their precursor or carbon source. So they are using metal catalyst. Okay, this is a metal catalyst, iron, nickel, and so on. So this kind of equipment, we also have this one in our university. So you can come to Nano Center or in SG or in Institute of Science if you want to see it. Some of you, I think, are already familiar or already seen this, what we call the synthesization apparatus in our lab. So this is the CVD reactor. So okay, this is a single furnace reactor, single furnace CVD. In our lab, we have single furnace and double furnace CVD in order to synthesize these carbon nanotubes. Okay, so that one is the final product. Okay, the CNT. Okay, so in the end, this product will be characterized using the characterization apparatus such as HRTEM, FESEM, and also Raman spectroscopy, which you will learn after this. Okay, in the next chapter. Okay, you can see. Okay, so this is the images from TEM method. Okay, the high resolution of microscopy. Okay, so for that, I'll end this session. Okay, thank you.